The next part of chapter 3, so now this is section 3.2, starting on page 67, we're talking about matter and how it can be divided into different classes. So we have mixtures and pure substances. So mixtures are composed of more than one substance, and they can be physically separated into its component substances. So mixtures, we can separate it out. Whatever was composing that mixture, we should be able to separate it out physically. Pure substances are composed of only one substance and they cannot be physically separated. So how would we separate a pure substance into smaller components? We'd have to do it chemically. There are two types of mixtures. So we have heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures do not have uniform properties throughout. So sand and water is an example. Another example, you could argue chocolate chip cookies because you can see the chocolate chips within the cookie. You could even say pizza is a heterogeneous mixture because you can separate out and see the cheese from the sauce and the pepperoni. Another example might be orange juice with pulp. So once the pulp is settled to the bottom, you can clearly see that you've got pulp at the bottom and regular orange juice at the top. All of those are examples of heterogeneous mixtures. Homogeneous mixtures have uniform properties throughout. So salt water is their example here because once the salt has been dissolved in the water, you can no longer see the salt from the water. You can't distinguish it with your eye. Sugar water would be another example, a cup of tea or a cup of coffee. So we know they're mixtures because we added our sugar and our creamer into the coffee, but we can no longer see the sugar. We can't see the creamer. We can't actually distinguish it with our eyes. Instead, we just see this new mixture that's like a lighter color brown if we're talking about coffee. Now there's two types of pure substances. So we can have compounds and we can have elements. So compounds can be chemically separated into the individual elements. Compounds are when we have multiple elements combining together through the formation of chemical bonds, which we'll talk about later. But compounds are composed of more than one element, and we can separate them, but chemically, not physically. So we'd have to do some sort of chemical reaction. Water is their example. It can be separated into hydrogen and oxygen, which we talked about. Antoine Lavoisier back in 1783 did that. An element cannot be broken down any further using chemical reactions. Now, elements themselves are composed of smaller particles, which we call protons, neutrons, and electrons, and we can separate those out. But we'd have to do experiments that involve nuclear chemistry, not just regular chemical reactions. So then here's a summary. So matter, again, we can have mixtures or pure substances, and to separate a mixture into a pure substance, we'd have to do some sort of physical separation. For mixtures, we can classify them as heterogeneous or homogeneous. Heterogeneous, you can definitely see the difference. So here they have an example of oil and water. Kind of everyone knows oil and water don't mix, so when you put oil in water, the oil usually floats on the top. A homogeneous mixture, so here they have an example of a sodium chloride drip that you might see in a hospital. So the different colors in here, the green and the purple, are representing the sodium and chloride ions. And then like we talked about, the red and white, those are our water molecules. Over to pure substances. So we have compounds and elements. To separate a compound into an element, you'd have to do a chemical separation. So here, their example is water. So when we have pure water, we can't see the individual elements. They're chemically combined. The hydrogen and oxygen are chemically combined to make water molecules. The point is it's multiple elements together. And then with an element, here they've got an example of gold foil. So this is just pure atomic gold atoms all together. It's only one element.